All right, so we do have some theorems here that are going to help us get through what we need to do. They're not broken apart, so I'm actually going to show you a little bit of how they need to be broken apart. So here you're given two functions, f of x and g of x, and they are the antiderivatives of little f and little g of x. And don't forget that c is a constant. So if you have a constant factor, meaning a coefficient, just like before when we were taking the derivative, you can essentially just kind of not think about that when you're taking the derivative. So when you are going backwards, I would kind of think about it like this. Bring your coefficient out front, integrate f of x dx, and then multiply by that c value, which is what you get here. Okay? So I just put it on the outside. No big deal. The integral of a sum. Basically, you can split these two apart. So you have the integral of f of x dx plus the integral of g of x dx. Okay, and that would be equal to these antiderivatives right here. And then the difference would be the same thing. So you have the integral of f of x dx minus the integral of g of x dx. Okay, and then as Zach pointed out, we do not have a product or a quotient rule, so that's what I'm about to address right now. Okay. So let's take a look at the first example. So first of all, whenever you have any quotients that are not constant values, for example, the third term, you need to rewrite this in friendly form. Okay, which means everything needs to be in the numerator. You cannot divide when you are integrating. You cannot divide. Okay, so you actually need to rewrite first. So this becomes the integral. This will stay as x to the negative 1/2. I'm going to write this whole thing out so that you see what the thought process is, but most of you will be able to do a lot of this stuff in your head. This then becomes minus the quantity of 8x to the 1/3 power plus 3x to the negative 1/4, and then plus 1/2. And this is all being integrated. So one thing that you need to do here, since we do not, this would, if I were taking the derivative of this, I'll move my hands in just a second. Isn't this a chain rule? If you were taking the derivative, which you're not, okay? We don't have a chain rule, okay, at least not yet, undoing the chain rule, so you actually need to distribute this power. So basically I'm asking myself, what is the cube root of 8 and then the cube root of x? Well, do I have a cube root of 8? I do. Do I have a cube root of x? Just x to the 1/3 power, right? You just leave it. Okay, so that way this becomes the coefficient. So we have the integral of x to the negative 1/2 minus 2x to the 1/3 power plus 3x to the negative 1/4 plus 1/2. And now we're going to integrate each term. Okay, so you need to clearly simplify every single thing as much as you can before you integrate. So now I can integrate each term. So if you go back up to, I think it's b, it'd be like integrating f of x, integrating g of x, h of x, k of, do you see what I'm saying? You're integrating each term. So when I integrate here, remember you are adding first. So this, I'm going to start right here, is equal to, when I add 1, what does it give me as a new exponent? It does give me 1/2. So this is x to the 1/2, and then you are dividing 1 by 1/2. What is that? It is 2. Because basically you're flipping it over, right? Yes? No? Yep? Okay.
Yes.
Thank you. Okay, so then this becomes minus 2x to what power? So I'm adding 1. So what am I adding? This becomes 4/3. I'm adding 3 over 3. So it becomes 4/3. Now you see here my exponent is a fraction. So when you divide by 4/3, what am I multiplying by? Yeah, 3/4. So I'm just going to put my 3/4 here. I'll simplify it in a minute. Most of you guys are going to start doing this in your head once you get more practice. We'll simplify this in a minute. This is plus 3x to what power? I heard it, 3/4. So then I need to multiply by what? 4/3. And then what happens here? Not yet. So let me ask you a question. This is essentially 1/2 x to the 0 power, true? Okay, so then you're going to add 1 and then divide by 1. So this is plus 1/2 x. So whenever you are integrating a constant, you're just going to put an x on next to it. Make sense? And then you get the plus c. I need to do some fixing, simplifying here, but the process is more what I'm concerned about. Is everybody okay? I tried to go nice and slow. Yes? Okay. So this is equal to 2x to the 1/2. What is that? Minus 3/2. X to the 4/3. Plus 4x to the 3/4. Plus 1/2 x plus c. Okay, again, I went slow for a reason. Okay, questions on the first one? Takes practice. Going backwards, a little bit more thought goes into it. Okay, because we're so used to the derivative. Okay. Oops, sorry. Do I have a product rule here? Yes or no? Do we have a product rule for integration? No, we do not. So there's a couple things that we need to do. First of all, I need to rewrite this as what? T to the, integral, t to the 1/2 times. You actually need to FOIL this out. So this becomes 1 minus 2t plus t squared dt. Can I integrate now? No, not yet. So when I distribute, if your bases are the same and you are multiplying, what do you do to your exponents? You add them. So this is the integral. Well, this is just t to the 1/2, right? Minus 2t to what power?
3.
Yep, 3/2. Plus t to what power? I heard it. It is. It's 5/2. Okay. So I haven't even integrated yet. There's a lot of prep that goes into this. Are we ready to integrate now? Yes, we are. Okay. So when we integrate, remember you add first. So when I add, I'm essentially adding 2 over 2, true? So this is t to the 3/2. But when you're dividing 1 by this, aren't you essentially just multiplying by the reciprocal? So what is this, 2/3? Is that right? Okay, look here. So you added 1 first, right? What's the coefficient right now? It's a 1. So you're taking 1 over the new exponent of 3/2. So isn't this 1 times the reciprocal of this, which is 2/3? Does everyone see how I got the 2/3? Okay. Then this is minus, let's add. So what is that, 2 over 2? 5/2. So this is t to the 5/2. What am I going to multiply this 2 by? 2/5? Yeah. So this is what, 4/5? But you see what I'm saying? Like it takes more thought. Like you have to be intentional. Okay? Plus, I'm adding 2 over 2, so what's my new exponent? 7 over 2, so what's my new coefficient? Perfect. And what do I have to make sure I put? Plus c. What if I wasn't sure if I got the right answer? What could I do to check myself? Take the derivative. Nice. Okay, questions. Again, it has to be intent, like you have to think what is happening here. So it takes a little bit more time. The more practice you get, the better you'll be. Just give it time. Okay? All right, questions before I move to the next one? You guys okay? Okay. Do I have a quotient rule? No, we do not. So what do? You literally divide. So I'm going to write out what I have. I have the integral of 2 over y minus 3y squared over y dy. Okay, this is what I'm thinking about. Okay? So this is easy to simplify. right? Okay, everything goes to the top. I want to show you something, though, off to the side. So first of all, what I really have here is the integral of 2 times 1 over y minus 3y dy. All I did was pull this fraction apart. And I pointed out on the previous page that the integral of 1 over x is equal to the natural log of the absolute value of x plus c. It is one of the rules that you need to know. It's on the previous page, but I just want to show you something. So let's take this all by itself. I have 1 over y. If I wanted to integrate that and bring it to the top, how would I write it? If y to the negative first dy. True? Okay. Now let's do this based on the rule. So I add 1. What happens when I add 1? So I get y to the 0. That's okay, right? Y to the 0? It's just 1. But I need to take the coefficient and divide it by the new exponent. What's the problem? You can't divide by 0. So do you see why this doesn't work using the rule? Which is why you need to know what the integral of 1 over y or 1 over x or 1 over k, whatever your variable is equal to. Absolutely, the natural log. So when I integrate, this is 2 times the natural log of the absolute value of y. Whatever y is, you would take the absolute value of it, so you must indicate the absolute value. And this becomes minus what? So what's the current exponent? 1. What do? You add 1, so this becomes y squared, and then what do you do with that 2? Divide. Or you're multiplying essentially by the reciprocal, which is 1/2. So it's 3/2. Just take the derivative really quick and it gets you right back, and then it's plus c. This, guys, it's just one to go back to and review. Okay, before I go to the last page, does anyone have any questions?